As you might expect from the name, there are three primary components of an MVC framework: one or more models, views, and controllers. These components define the response cycle of a user interaction with an MVC application. The model is a domain-specific set of classes that provide an interface into the data, whatever data you're using behind this application. It also implements business rules, as well as stores application state. The model may or may not wrap a persistent data store such as SQL Server or some other database server. Usually the model will consist of some kind of data access layer or some kind of object relational tool such as Link to SQL, Entity Framework, or NHibernate. And there's a whole bunch of other ones that you can use. You're really unlimited in terms of the technologies that you use to define an MVC model. The second component is a view. This is the application's user interface, which essentially renders the model in a form that the user can interact with. So you can think of it as a transformation of the model, of the data behind the application. An application is going to typically have multiple views associated with a single model, each of which is used for different purposes. In a web application, the view is usually defined by HTML and contains no code or logic other than the logic that is necessary to render the user interface to the user, including things like data validation. The whole point is the view allows the user to interact with your application. And then the third component is the controller. The controller receives requests from the user and then initiates some kind of a response, whatever is appropriate for the application in that state based on the user interaction. And then the controller interacts with the model as is necessary to change state or save data or whatever needs to be done. The controller also handles the overall application flow. In a web application, the controller usually responds to HTTP GET or POST inputs, then hands the request over to the model that implements the business rules, and then selects the view displayed to the user. So some fairly complex interactions going on there. The user's interaction with the application usually follows a specific pattern. First, the user interacts with a web page in some way, maybe making selections from a form, clicking on a button, whatever the user does on the web page. Then the controller handles the input and then routes that request to the appropriate action, which is usually a public method of the controller class, called an action method. Third, the controller notifies the model of the user's action, usually resulting in a change to the model's state. Keeps track of what's going on and what's happened. Fourth, the controller then selects a view, which queries the model, uses the data contained in the model, in order to generate a new web page. Essentially what's happening is the controller tells the view to generate itself based on the current model state. And then the user interface, the web page, awaits a new interaction from the user, and the whole cycle starts over again. Here's a graphic depiction of how the various MVC application components interact with each other to handle a user request and generate a response. So you have the HTTP request coming in, goes into the controller, it interacts with the model. The model may or may not hit some sort of persistent storage, such as SQL Server, returns data to the controller, selects a view, and that results in a response that's sent down to the browser. Now, if you're familiar with ASP.NET Web Forms development, notice that there are no page events involved in responding to a user request. The whole page cycle that you might be familiar with is gone. Doesn't happen at all. This makes for a much cleaner, simpler, and more maintainable architecture for an application. So ASP.NET MVC is Microsoft's newest framework for developing web applications, and it supports pattern-based development to make it easy to implement design principles and patterns. It's an integral part of ASP.NET, which is part of Microsoft's huge .NET framework for building Windows applications of all types. MVC is an alternative to, but not a replacement for, the ASP.NET Web Forms framework. The first implementation of the ASP.NET version of MVC was created by Microsoft's Scott Guthrie, who's often called the father of ASP.NET for his role in the original version of ASP.NET. He created MVC on the way to the very first Alt.NET conference in Austin, Texas in October of 2007. That implementation was extremely simple, but it generated a lot of interest and became a product when Microsoft released MVC 1.0 in early 2009. And then Microsoft followed up with a greatly improved and much more mature version 2.0 in March of 2010. Now, it's very important that you understand that ASP.NET MVC is built using the core ASP.NET features, and it uses HTTP handlers and HTTP modules to implement the various features. It's not a whole new ASP.NET. In fact, it shares much of the web request response architecture with web forms, albeit without all the baggage that web forms use to abstract away web protocols. So let's talk about some of those differences. Now, Microsoft introduced the .NET framework in ASP.NET back around 2002. It replaced their antiquated active server pages, or ASP. ASP.NET, when it first came out, was a revolutionary technology that brought a server-side framework and services to overcome the limitations of the web as compared to desktop programming. The primary web development technology in ASP.NET initially was, and really still is, web forms. ASP.NET Web Forms provides a rich infrastructure for developing the web equivalent of desktop applications. One of the issues with web development is that HTTP is a stateless protocol, meaning that it doesn't retain any state information between web requests. For example, in order to implement shopping carts, keep users logged into a site, and return other kinds of information between requests, a web application has to collaborate with the web server to provide some kind of state information. Now, Web Forms provides various technologies to retain state between requests, including view state. View state is implemented as a block of data in a hidden element on the web page, passed back and forth between browser and server with every request and response. If you've ever created a web form, particularly one with a large server control on it, such as a grid or a list view, and then look at the page source, you'll see just how large view state can get. But the nice thing about view state is that you can implement server controls that provide a rich user interface that retain information between each request because it's stored within that hidden field on the form. View state also makes possible server-side events that respond to changes in the data in the view state. So with every request to the page, these different events can look at the changed data within view state and then raise events. All of these technologies, including view state, serve to give the illusion of the look, feel, and functionality of a desktop application. It's a very high-level abstraction of how the web works. At development time, the combination of ASP.NET and the designers that are built into Visual Studio provide a drag-and-drop development interface. It's built on the development style that was implemented in early versions of Visual Basic, which let a developer drag and drop server controls onto a web forms page, set a few properties, and then run the page that has the feel of a desktop application. It really is a pretty magical interface. This kind of development experience became very popular in the decade of the 2000s, as did other web development frameworks, both on Windows and in other environments. But web forms come with some serious baggage, of which a few are probably the most significant. The first is that a developer has very little control over the HTML that's generated by the built-in server controls. The controls, particularly in the initial versions of ASP.NET, often generated bloated, table-based, non-standards compliant code, which can cause all kinds of problems with client browsers. Fortunately, Microsoft has improved the generated code over the years, and in ASP.NET 4.0 it's far better and you have far more control. And they also have introduced templated controls that give you more control. but you still can't completely define the HTML generated by your application. Amongst other problems, this makes it very hard to use cascading style sheets to provide a uniform look and feel throughout an entire site. I talked a little bit about view state. It's the foundation for many of the powerful web forms features, but it can quickly become bloated, which really increases the amount of data passed between the browser and the server with every single page request. It can bring a server to its knees if you have a very active site. Complex server controls like grids can add hundreds of kilobytes of view state data to a page if you're not careful, and you do have some control over that. Unfortunately, if you use the default view state settings in a page, you may not even be able to use most of that bloated data. Unit testing and other forms of code testing have really become popular over the last few years, for the most part after Microsoft introduced ASP.NET. Unfortunately, it's very difficult to write unit tests against a web forms page because of all of the dependencies on various objects required for the page. Probably my biggest problem with web forms is that even if you're very experienced with ASP.NET, you can find yourself completely befuddled by the events that make up the page lifecycle. The lifecycle of an ASP.NET page, web forms page, is reasonably well documented, but the sheer number of events can make it extremely difficult to figure out how and where to implement code. This can lead to highly fragmented code, small snippets scattered throughout a code behind page in many different kinds of events. I've gotten to the point where when I develop a web forms application, it just always feels like I'm fighting web forms, fighting these events in the page lifecycle in order to accomplish what I need to do for an application. Now, ASP.NET MVC overcomes these kinds of problems by giving the developer complete control over the HTML generated, as well as a highly extensible framework. So you can customize almost any part of it. But the price you pay for these kinds of benefits is typically that you have to write more code. But with Visual Studio and the MVC APIs, it usually turns out to be really not all that much more code, as you'll see throughout this course. Let's talk a little bit about the tenets of MVC that accomplish the goals of providing you with more control over the application. The first and probably most important is separation of concerns. A foundational concept of good application design is that an application should be modularized, so that each module focuses on its own concerns, with as little knowledge of other modules as possible. In MVC, the model knows nothing about a view or controller. The view knows nothing about the controller, and so on. Now that's the ideal, but the more that you can keep the concerns of the different components separate, the better your application is going to be. It's going to perform better, it's going to be more maintainable, and so forth. So that's separation of concerns. Another important tenet is convention over configuration, and the ASP.NET version of MVC really makes use of this. The idea is that ASP.NET MVC eliminates the need for extensive configuration settings by following various conventions. For example, an MVC project has separate folders for controllers, views, and models, conventional locations to locate the code files that implement those different components. By keeping those components in the conventional folders, you don't have to make extensive configuration changes. And you'll see that throughout this course, where you see how clean the code can be, because when you follow convention, you don't have to do a lot of configuration or specify paths and so forth. Another tenet is keep it dry. Don't repeat yourself. Dry is one of the design principles that MVC embraces, and this isn't specific to ASP.NET MVC. It's a critical part of the original MVC pattern. The point is you should eliminate duplication of code and logic. And that has the obvious benefit of making an application faster as well as easier to maintain. One example of this is that you can decorate a model with attributes that support validation. So those attributes are in the model. That way, no matter how many views use that model, they all enforce the exact same data validation rules. You don't have to keep